Now we are seeing a problem from the topic centroid. The corner of a plate is cut off and a hole of diameter 50 mm is punched as shown in the figure. The center of the circle is at a distance of 50 mm from the left and bottom edges of the plate. Calculate the position of centroid for the remaining portion. So here plate is given for which is given plate is the corner of the plate is cut off. So the corner of the plate is cut off like this triangle shape, and also a hole is punched in this plate, and the diameter of the hole is 50 mm, and it is punched such that the center of the hole is lying at a distance of 50 mm from the bottom edge and also 50 mm from the left side edge. So like this it is cut. So for this remaining portion, means after cutting the edge of the plate and punching the hole, for this remaining portion we have to find out the centroid location, that is x bar y bar we have to find out. So to find out the centroid location for this remaining portion or this shaded area, so if you observe this area is not a regular figure. So for that purpose we have to use the formulas of x bar and y bar, that is to find out the centroid of a complex shape, means it is a complex shape, it is not regular shape. So we have to use the formulas of x bar and y bar to calculate the position of the centroid for this remaining portion. So we know the formulas of centroid of a complex shape of, that is x bar and y bar, as a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and also y bar as a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. But we have taken a1 into x1 minus a2 x2 minus y, because if you see the given question here, this area and this area is removed. First of all, we'll take this, or we'll divide this complex shape into simple figures. So if you divide the given complex shape into simple figures, first of all we'll take the total the figure 1 or area 1 as a total rectangle, that is 150 by 120. We'll take it as a total rectangle having total material, and from that we are removing a triangular area, that is area 2, and the circle area 3. So like this we have divided the given question. So here, so to get the centroid of this remaining portion, so we are removing this area 2 and area 3. So for that reason we have to write here the formula a1 x1 minus a2 x2 minus a3 x3 by a1 minus a2 minus a3, because area 2 and area 3 we are removing. And also here also y bar formula a1 y1 minus a2 y2 minus a3 y3 by a1 minus a2 minus a3. So these formulas we have to use here, and so we have divided the given question into simple areas. So here we have to find out x1 x2 x3 y1 y2 y3 to get the x bar y bar for this remaining portion. So first of all, so if you see, I told this we have taken total rectangle, that is 150 by 120 rectangle as a area 1. So for that, if you write x1, that is a, so x1 is nothing but center or centroid location of this total rectangle, that is 150 by 120 from this left side edge, so along the x direction. So it is 150 means, so the center will be 75 mm from this left side edge. So in the same way x2, suppose if you take x2, we have taken this triangle as a second area. So x2 means distance of centroid of this second area from this left side. So that will become means from this left edge to this point we require distance in the x direction. So that will be from here to here 80, it is given in the question, and we require from this point to this point, this distance we require. So if you see the this area separately, if you assume that, if you see this right angle triangular area separately. So we know the position of centroid of this right angle triangle is, suppose if you take this as a base and this as the height, suppose 60 as a base and 70 as a height. So this position of the centroid of this right angle triangle will be b by 3 and h by 3, means from this it is of h by 3 height, means centroid, and from this edge it is b by 3. So this is the location of centroid. But we require from here to here. So from here to here we will know it is h by 3 and it is 2/3 of h. So it is 1/3 of h. Suppose if you take this total as 70 as h, this is h. So we know this from standard formulas. This is 1/3 of h. So this will be 2/3 of h. So we require from this left edge to this center, means so it is 80 plus 2/3 of h. So h we have taken 70. So x2 will become 80 plus 2/3 of 70, that is h means 70. So if we simplify that, we are getting x2, that means the centroid location from this left edge of the plate is from here to here. So that is 126.67 mm. And in the same way, x3 means position of the center or centroid of this circle from this left edge of the plate is 50. It is given in the question. So means the hole is punched from such that the center of the hole is 50 mm from the bottom edge and left edge. So this distance means the center distance from this left side or left edge of the plate will become 50. So x3 will become 50 in this case. And the same way, y1, y2, y3 means position of centers of area 1 from this bottom edge. So y1 means that is total is 120. So center location from this bottom edge means in the y direction. So it is 60, because 120 and a half will be 60, means we are taking this total rectangle 150 by 120 total rectangle. Center will be at the middle, so by default the y1 is 60. And next is y2. So this position of this point from this bottom edge, so means from here to here. So from this bottom edge to this, the y direction distance we require, that is y2. So that we'll get this from here to here, it is 60, and we require this distance, means from this point to this point, this distance we require. So I told this is suppose we have taken this as a b and that is 60. So we know this distance, that is 1/3 of b. So this will be 2/3 of b. So to get the distance of this point, this center point from this bottom edge, so it is 60 plus 2/3 of 60, means this 60. So we can write 60 plus 2/3 of 60. So 60 is this distance and 2/3 of 60 is this, such that we'll get this distance. 2/3 of 60 will give this distance from this point to, means from here to here we'll get. So if you simplify that, we are getting y2 distance as 100 mm, means the distance of this point from this bottom edge is 100. And next y3. So this is the third area, that circle area. So this already given in the question, that is center of the circle is 50 mm from the bottom edge of the plate. So y3 will become 50 mm. And next we require areas a1, a2, a3. So I told we have taken total rectangle as area 1. So the area will become 150 by 120, that is 18,000 mm square. And a2, so we have taken this triangle as a2, area 2. So half into base into height, half into 60 into 70. So we are getting a2 as 2100 mm square. And a3 is the circle area. So it is given in the question, circle of diameter 50 mm, so radius will become 25. So and area of the circle is pi r square. So pi into r square, r value 25 square. So if you simplify that, we are getting area 3 as 1963.5 mm square. So we got areas and x1, x2, x3, y1, y2, y3. So substitute these values in the x bar and y bar formulas. So first of all, if you see x bar formula, a1 x1 minus a2 x2 minus a3 x3 by a1 minus a2 minus a3. So I told why we have to take minus. So A1, area 1 we have taken total plate rectangle area, total area. So, but we require only remaining portion, means after cutting this second area, third area, we require centroid, means so we have to remove this second area A2 x2, and we have to remove this also A3 x3. So for that purpose we have taken here minus A2 x2 minus A3 x3 by A1 minus A2 minus A3. So if you simplify all these values, area values, and x1 x2 x3 values here, and when you simplify that, we are getting x bar formula, x bar value as 70.73 mm. And in the same way, if you write y bar formula, a1 y1 minus a2 y2 minus a3 y3 by a1 minus a2 minus a3. And if you substitute the areas and y values here, and when you simplify that, we are getting y bar value as 55.38 mm. So this is the way to solve or to find out the centroid of this remaining, or here if you see this remaining portion. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.